Alright, so on this board I have a right triangle. And as we know, so here is the right angle here, and normally we have two sides that are adjacent to this right angle. So a right angle just means that it measures 90 degrees. So given a triangle that is right, or that has a 90-degree angle, we know that the sum of the squares of the two adjacent sides is equal to the sum of the square of the hypotenuse. And the hypotenuse is the longest side, which is opposite of the 90-degree angle. So we have this rule that says that a squared plus b squared equals c squared. Now, why is that? So, in this brief video, I will just go through the proof of the Pythagorean theorem, and then we'll see exactly why the Pythagorean theorem is true. Okay? And the argument essentially just works by similar triangles. So let's take a look. Alright, so this is the same right triangle, except what has happened now is that they have dropped this line here, which is a right angle here too. So that kind of divides the triangle up into two parts. And so the original triangle, is this big one, and now there's two smaller triangles inside. Now what's interesting is that these triangles are actually going to be the same. So let's just call this side length h. So of course there's the really big triangle, which is going to be ABC, as you already see, and it's going to have this angle theta here. Now what's going to happen is if you look at the smaller triangle, it also has this angle theta, and it has side length, B, H, and D. So now if you just reorient this triangle by rotating and flipping it around, you see that the side length, so these triangles are not to scale, I'm just showing how they're related to each other. So you're going to have the angle here, and now the two sides that are adjacent to this right angle are D and H. So D is a shorter side and H is a longer one. And B is going to be the hypotenuse in the smaller triangle here. And finally we have a third triangle, and this also has a right angle and an angle theta. And so the two sides that are going to be adjacent to this right angle are going to be E and H, and E is the longer side. So let's draw that. And then A is actually the hypotenuse of this triangle. And so this one is going to be the angle theta. Okay, so now how does this actually help us prove the Pythagorean theorem? The whole thing is that, by decomposing this large triangle into three triangles, we have actually created three similar triangles. Okay, so let me just turn off the graphic. Right, so what does that do for us if we create three similar triangles? Well, one of the facts for similar triangles is that ratios of sides are always going to be the same. So what does that mean for us? Well, that means that in this triangle, the ratio of B to C is going to be the same thing as the ratio of D to B. Right? So let's first write that down. So that means that B is to C as D is to B, because these two are similar triangles. Of course, this triangle is much bigger than the other one, but they're not drawn to scale. Now, what's another one? Well, also that A is to C as E is to A. So we can also write that rule down. Okay, so A is to C as E is to A. So A is to C as E is to A. Okay. So from these similar triangles, we get these two equations, right? So now I'm going to erase the similar triangles and just look at these equations. So now if we just, cross multiply on this, for this equation, we get B squared is equal to C times D. And if we cross multiply on this one, we get that A squared is equal to c times e. Okay? Well, now what does that say for us? Well, it says that a squared plus b squared is going to be equal to, well, when first we substitute in what a squared is equal to. A squared is equal to c times e. Plus, and now we substitute in what b squared is equal to, and b squared is going to be equal to c times d. Okay? But now, there's a rule in algebra called the distributive law. So that means that c times e plus c times d is really going to be the same thing as c times e plus d. Okay? So we get that a squared plus b squared is equal to c times e plus d. Okay? So all we've done at this point is we decomposed the large triangle into 3 triangles, created similar triangles, got the ratios of those similar triangles, manipulated them a little bit algebraically, and then we were able to come up with this expression. Of course, that's still not what we want, but we're really close. So now that we've arrived at this step, I'll just erase all the steps before. Let's bring back the original diagram. Okay, now if you notice, this is D, and this is E. So it becomes exactly apparent that C, the side length C, is exactly equal to E plus D. Okay, and here we have C times the quantity E plus D. But E plus D is exactly the same thing as C. So that's just going to be C times C, or it's going to be C squared. And so now, just, so we have A squared plus B squared, and we go all the way down, we get is equal to C squared. And that concludes one possible proof of the Pythagorean theorem. And of course, there's a lot of different proofs, but this is just one of the possibilities, and I guess that's good enough to convince us that it's true.